Let me just check the question that I gave. Okay, there it is. Okay, so bracket minus and then bracket and then 6. Okay. Yes. Yeah, Hiva, what's the doubt in this?
I didn't understand this question.
Okay. Hiba, first, okay, forget about this part. Just tell me, if you expand the left hand side, what will you get? Try expanding this using one of the properties. Yeah, Hiba, which property do you think you can use here?
Distributive.
Yes, exactly, distributive. So apply that property and tell me what comes out.
Uh,
Yes, Hiba.
-5.
Yes. Go ahead.
+1.
+1.
Sorry, +4.
Yeah. +4.
3 + 6.
+6.
Sorry, 3 × 6. Sorry.
Wait a minute.
3 - 6.
Okay. So that is the question, right? -5 + 4 4 bracket, open bracket, 3 - 6. So when you apply the distributive property in this, what does it become? Okay. So for the time being, I'm going to erase this part. Okay. I'm going to erase this part. Now tell me what will happen if you apply the distributive property in this.
4 × 3.
Yes.
-4 × 6.
Okay. Now, what will happen if I add a -5 over here? So over here also, it's this same -5. I'm just adding it, right? So the same -5 I will add over here also. Yes or no?
Yeah.
So can you compare this with this?
-5 + 4. 3 - 4.
Yes. So what should be there in the two blanks? This is
3
blank
and
number
4.
1 and blank number 2. Yes. 3 and 4. Okay. So any other doubts?
Can you give me one question related to this? I will try to do this.
One question. Okay. So you were able to do the first question. The first part of the question, you were able to do it?
Yeah.
Okay. What was the answer?
What do you mean by that?
What was the answer in the first part of the question? the first part of the previous question. So this, fill in the blanks and write the name of the property used, right? This has two parts, part A and part B. The one that you just told me is part B. So I'm asking you, what was the answer for part A? Did you understand my question now?
Yeah.
Yeah. Tell me.
Wait, I will bring that question. I don't remember.
Okay.
It was minus 16 and the property was
Very good.
commutative.
Okay, very good. All right. Then the next question. The next question, which says, find a pair of negative integers whose difference is minus 41.
Minus 45 minus minus 4.
Okay, so the pair of negative integers. So we need two negative integers. Oops, sorry. Whose difference is minus 41. So we need minus 41 and there should be a negative sign. You are saying minus 45 and?
Minus 4.
Very good. Okay, because then that becomes minus 45 plus 4, right? And that becomes minus 41. Excellent. Okay. All right, next question. A negative integer and a positive integer whose sum is minus 10. Just a minute. A negative integer and a positive integer whose sum is minus 10. Yeah.
Minus 15 plus 5.
Minus 15 and plus 5. So their sum is minus 10. Yes. Okay, very good. All right. A negative integer and a positive integer whose sum is 0.
Minus 5 plus 5.
Very good. Okay. So we're done with this chapter. I will be giving you a worksheet. Okay. A worksheet. It will be for the entire chapter. All right. And yeah, so you'll be giving that worksheet.
But can I ask you something?
Yes.
When there's a question like write a negative integer and a positive integer whose sum is like any number. So can we also write it like positive first and then negative?
Yeah, of course. No problem. Same thing. Okay. All right. So let's, do you want to start the next chapter, decimals and fractions? Actually, the next chapter is fractions only, right?
Fractions and decimals.
Yeah, fractions and decimals. Give me a second. Okay. All right. So if you want, you can like write the heading down. Fractions and decimals. All right. So let's just recap a little bit to see how much you know about fractions and decimals. Okay. Just a minute. Okay. So, Hiba, can you give me an example of a fraction?
7/4.
Sorry,
8/4.
8/4. Okay. Hiba, what kind of fractions do you know? What are the different types of fractions?
Improper fraction.
Sorry?
Improper fraction and
Okay,
proper
improper
fraction.
fractions and proper fractions. Okay. Is there something we can do to change improper fraction and then it becomes something else, a different type of fraction? What is that
Yeah.
different type of fraction called?
Mixed fraction.
Mixed fraction. Okay. Can you give me example for each of them?
Yeah.
Yeah.
For improper fraction also.
Yes, each of them.
Okay. Improper fraction. A 5. Sorry.
Okay. Hmm.
1/5.
1/5 is what type of fraction?
Improper.
Improper. Okay. First, tell me what is an improper fraction? Like, what is the definition of an improper fraction?
They're like the denominator is bigger. No, sorry.
Okay.
The denominator is smaller
Hmm.
and the numerator is bigger.
Okay. So, Hiba, see, the thing about proper fractions is that when we first start learning about fractions, right? Like, for example, if you have like a cake, okay, or no, not a cake, if you have a pizza, okay, and usually how many we have like six slices in a pizza usually, right? So I am saying that, okay, this part, this is how much in fractions, how much will this part be?
1/6.
1/6. So basically this is a proper fraction. Okay, this is a proper fraction. And what a proper fraction means is that it is a fraction that represents a part of a whole. Okay, a part of a whole. Is that clear? So what that means is that, so whenever you have something that represents like, you know, it is a part of something, like 1/6 means one part out of 6 parts, right? If I say 2/3, that means you have something, okay, that has 3 parts, and 2/3 means that we are talking about 3 parts out of the, sorry, 2 parts out of these 3 parts, right? So that is what a proper fraction means. Then obviously, what will an improper fraction mean? Improper fraction will be the opposite of that, where the denominator is smaller and numerator is bigger, right? So an improper fraction will be just the opposite of that. So now can you give me
5/2.
examples?
5/2.
Yes, 5/2. Proper fraction, one more example. I have already given you 2 examples. Give me one more example of a proper fraction.
7/20.
Okay, very good. 7/20. Can you give me an example of a mixed fraction?
Yeah. 3/7.
Okay, very good. Okay, what does 3/7 mean? How can you represent it in parts?
First, we'll multiply 1 and 7,
Okay,
and then the answer we will plus it by 3. So it's going to be 10. 10/7.
10/7. Very good. Okay, this will be equal to 10/7. 10/7. That these two are equal. 10/7 is equal to 3/7. Oops. My question, Hiba, is if I have this, okay, if I say 1 1 by 2. Is this, what kind of a fraction is this?
Mixed fraction.
Mixed fraction, very good. Okay, Hiba, you know what is 1 by 2, right?
Yeah.
Can you tell me how will it be if I try to show it in the form of a picture, in the form of a diagram, you know, pictorially, if I try to show it?
Um,
How can I show 1 by 2?
like any food with it's like divided, like it has a cut in between.
Yeah, yes, it is divided through the middle. It is divided in the middle. Let's say we have like a roti, you know, a chapati or something like that. Okay. And we divide it right in the middle into two equal halves. So now what will 1 by 2 be?
We will eat one.
Hmm?
If we eat one, it's going to be 1 by 2.
Yeah. So one part of this is going to be 1 by 2, right? Okay. So this is 1 by 2. Okay. Now how can I represent, this pictorially? What does this mean?
Can
What
you
does
read the
1 by 2
question?
mean? Sorry?
Can you read the question? Like 1 by 2.
Okay, my question is, what does 1 by 2 mean? Do we ever use it in our real life?
Yeah, it's
How?
3 by 2.
Yes, it's 3 by 2. Have you ever bought 1 by 2 kgs of something? How
No.
much is it? Okay, can you tell me whether 1 by 2 is bigger than 1 or is it smaller than 1? Is it bigger than 2 or smaller than 2? Is it bigger than half or smaller than half? 10. 1 by 2.
It is smaller than 1. Sorry, it is
Okay.
bigger than 1.
Yes, it is bigger than 1. Okay. Then
It is same as 2. Like it is equal to 2.
Siva, just give me 1 second. I have to open the door. Just one minute. So yes, where were we? You said it is greater than 1, and then after that, is it equal to 2 or greater than 2 or smaller than 2? Yes, Siva? Can you hear me?
Sorry, my mic was muted. It
Okay.
is smaller than 2.
It is smaller than 2, pakka?
Yeah.
Okay, it is smaller than 2. Is it greater than half or less than half?
It is equal to half.
It is equal to half. Okay. Hiba, you told me that it is greater than 1, right? So let's look at the number line. And this is my number line. Let's say this is my 0. This is 2. Right in the middle comes 1. Right in the middle of this comes half. Okay. So you're saying that it is equal to half, but you're also saying that it is greater than 1, right? It is greater than 1. So greater than 1 means it should be somewhere over here. And you also said that it's less than 2. So it can't be beyond 2, right? It can't be beyond 2. So it has to be before 2 and after 1. Why? Because it is greater than 1 and it is less than 2. So it has to be somewhere over here. So you can't say that it is equal to half, right?
Yeah.
But okay, tell me what made you think it is equal to half?
Because the answer will be, I thought the answer will be 1 by 2.
Answer for what?
1 2 by 2. 1 by 2. But
Okay,
it is actually smaller than 1 by 2. Right?
smaller than 1 by 2.
Yeah.
Hiba, are you sure? Just now you told me it is greater than 1.
But now I think it is smaller than 1 by 2.
Okay, tell me what makes you think 1 by 2 will be, so here we have 1 by 2 and here we have 1 by 2. So tell me what makes you think it will be smaller?
Because 1 by 2 is 3 by 2.
Okay, just a minute. Let me write that down. This is equal to 3 by 2 and this thing is equal to half. So you are saying which one will be smaller?
3 by 2.
3 by 2 will be smaller. And why?
Because it is improper.
Okay, because it is improper fraction. So does it mean that improper fractions are smaller than proper fractions? Or why?
Yeah.
Why do you think, like what makes you say that an improper fraction will be smaller than a proper fraction?
Because we can't divide it.
Okay, we can't divide it. Like you are saying that the way that we can represent half in this way, we cannot represent 3 by 2. Is that what you're saying?
Yeah.
Okay. So here comes the magic, Hiba. Let me just show you what is going to happen. So I have 3 by 2. And you said that 3 by 2 is nothing but equal to 1 by 2.
Yeah.
Right? This we call it 1. Okay, 1. Or let me just do this. Let me just quickly do this. This is equal to 1 by 2. Okay, I'm just rewriting it and I'm just coloring it in a different way. Don't be confused. This is equal to, we call it 1 and a half. Have you ever heard of this term before? 1 and a half?
Yeah.
Right? So this is 1 and this is a half, right? So we call it 1 and a half. Have you ever had 1 and a half chapatis, Hiba? Do you know what 1 and a half chapatis look like? Hmm? Hiba?
No.
No, you don't know what it looks like? Okay. Okay, so tell me what food do you usually have for lunch, for dinner, for breakfast? Hmm? I can't hear you.
Right.
I still can't hear you. Hiba, am I audible to you?
Yeah.
Huh. Tell me. So I just asked you what do you usually have for lunch, for breakfast, for dinner?
A roti.
Hmm?
Sometimes like a roti and bread.
Okay, roti and bread. So so can you tell me how much one roti is like? One roti is basically just one circle. Is that right? That's right. That's one circle. And then I'm going to draw one more roti. Okay, because our moms don't make half a roti, right? They will make one roti. They won't make half a roti. They'll make one. So let's say I want to have 1.5 rotis. Okay, let's say um today I ate one roti for like lunch, and I usually eat 2 rotis for dinner. I'm just giving an example. Okay, but I don't feel like eating, so I say, well, I want to eat more than one, but I don't want to eat two, so I'm just going to eat 1.5, because that's between one and a two, 1 and 2, right? So Hiba, am I right? Is 1.5, is it true that 1.5 lies between 1 and 2? Is it true?
Yeah.
Yeah. So so Hiba, just look over here. Okay. Uh, okay, so this is my one roti. So if I'm having one roti, this is my one roti. If I'm having two, then I'm gonna eat both of these. Okay, so both of these colored portions I will eat. But let's say I don't want to have 2 rotis. I only want to have 1.5. So how much will I eat? This much,
Uh,
right?
1/2. So 1.5.
Is this equal to 1.5?
Yeah.
Yeah, just a minute. Let me color it properly. Okay. So this is equal to 1.5. This is equal to, this total orange portion is equal to 1.5. Let me just rewrite that. This total orange portion is equal to 1.5. All right. Now let's see what is half of a roti. I'm just going to draw half. Let's say there's a small kid in my house, like maybe she's like 4 or 5 years old. Okay. And she eats only half a roti because she's very tiny. So how much portion is she going to eat? Half. How can I draw half?
You just cut
Yeah,
it in
just
the middle.
color half of the portion. Is this equal to half a roti?
Yeah.
Yeah. So I am gonna write it like this. I'm gonna write it like this. 1 minute. This is equal to 1/2. This is equal to half, right? 1/2 means half.
Yeah.
Right? Okay. So now can you tell me which one is bigger? Look at the 2 rotis. Okay, look at the 2 portions. How much has been eaten? I have eaten 1.5, and my little sister has eaten half. Okay, tell me who has eaten more.
You.
Okay, so now which one is bigger, half or 1.5?
1.5.
1.5. Now take a look at this and tell me, this 1.5, where should I place it? Again, I will ask you the same question. Will it be equal to half?
No.
No. Will it be bigger than 1/2?
No.
Will it be bigger than half? Will it be bigger than half?
Yeah.
Yes, it will be bigger than a half. So where will it lie? So let's say this is my green portion. Okay, this is my blue portion. That's my yellow portion over there. And this is my orange portion. Okay. Tell me where will my 1.5 lie? This thing, 1.5. Where will it lie? In which portion? Green, blue, yellow, or orange? Sorry?
Blue.
Blue. So that means it is, you are saying that 1.5 is smaller than half. This is half. This is half.
Green.
Green. So that means 1.5 is, the green portion is over here, right? So you're
Yeah.
saying that 1.5 is smaller than 1?
Yeah.
Is it smaller than 1? Take a look. This is 1.5. Is it smaller than 1 or bigger than 1? How much is 1?
Can you go back to the previous?
Yeah.
It will land on yellow.
Yes. Very good. It will lie on the yellow part. How did you come to that conclusion?
Because 1/2 is smaller than 2.
Yes,
And
it is small.
bigger
It is
than
bigger
1.
than 1. And how did we come to that conclusion? It is bigger than 1 because over here, if you look at it, this much is 1. This is 1 roti, right? 1 roti is obviously smaller than 1.5 roti. If I say I have eaten 1 roti and Hiba has eaten 1.5 roti, that means Hiba has eaten more than me, right?
Yeah.
Yeah. So we can obviously say that 1 is smaller and 1.5 is bigger. So 1.5, as you said, as you correctly said, it lies in the yellow portion. Now, okay, so this yellow portion also, I'm going to divide it in 2 parts, okay? So this is the exact midway between 1 and 2. So tell me whether my 1.5 will lie, now it will lie in the yellow portion or it will lie in the purple portion, or it will, which color do I have left? I don't even have any colors left. Okay, I have this red. So, or will it be on this red dot? Yes, Hiba, you are muted.
Can you repeat the question again?
Yes. My question was, you said that it will lie in this portion, right? Okay. But in this portion, where will it further lie? Will it be in the yellow portion now? Will it be in the purple portion? Or will it be on the red dot? The red dot, again, it is exactly halfway between 1 and 2.
Yeah, it will land on the red dot.
Yes, it will lie on the red dot. That means, basically, that means that this red dot, this is equal to 1.5. Okay, so you said that, you were confused about 3/2. 3/2 means 1.5. Okay, how are we saying 1.5? This means, this is nothing but you take this 1 plus this thing, half. Okay, so when these two things come together, 1 and half, they two come together, it becomes 1.5. Okay, so similarly, like if I say 5 and 3/4, okay, so how can you separate them? What does this mean? It means you have 5 of something, 5. Let's say if I'm saying 5 and 3/4, again, I'll take the example of roti because it's the most relevant example. So if I say 5 and 3/4, it means 5 rotis I have, and I'm adding to it how much? 3/4.
And 4.
Is that clear?
Yeah.
Okay. So, all right. So now you're clear with the concept of improper fractions, right? So if I, for example, if I ask you which one is bigger, 4 or 17 by 3?
Can you write it a little down?
Okay. 1 minute. Which one is bigger, 4 or 17 upon 3? How will you find out?
4.
4 is bigger, pakka?
Yeah.
First of all, let's try to, okay, basically what 4 is, can you write 4 as, okay, let me just give you this example. See, we have 3 things, right? You told me there are 3 types of fractions. One is improper fraction. And the other is mixed fraction. And the third one is a proper fraction. So I'm not going to touch that. I'm just going to touch these two, improper and mixed. You said that we can keep changing them. Like improper fraction, we can change it to a mixed fraction, and a mixed fraction that can become an improper fraction, right? It can keep changing. So can you tell me whether what type of a fraction is this?
Proper fraction.
Sorry?
Proper fraction.
Proper? What type of fraction is this?
Improper.
And why is this proper?
What is the difference between proper and improper?
Yes. Proper fraction, just write it down, or if you want, you can take a screenshot. Proper fraction is one where the numerator is small and denominator is big. So that's what I told you in the very beginning, that a proper fraction is a part of a whole, okay? You can just take one part, you take one something, okay? Like for example, one roti or one cake or one chocolate, only one, not many, just one. Like in this case, we took 2 rotis, right? So
Yeah.
if you have to take 2 rotis for something or 2 objects for something, then that means it's not a proper fraction. A proper fraction will only be when you have only one of that object, okay? You take one of that object, divide it into parts, this much part of it, that will be a proper fraction, or this much part of it, that will be a proper fraction. So yeah, proper fraction is, for example, 1 by 4, 2 by 5, okay, 7 by 10, or 5 by, I don't know, 40, okay? These are all proper fractions. 1 by 3. This means that numerator is small, numerator is smaller than the denominator, okay? As you can see, in each case, the numerator is smaller than the denominator. This is the numerator. Numerator is smaller. Okay. And the improper fraction is basically just the opposite of that.
The denominator is smaller than the numerator.
Yes. I'm sorry, I just got it. Yeah. In a improper fraction, the numerator is bigger and denominator is smaller. Okay. So now tell me about this. 4 by 1. What kind of a fraction is it?
Improper.
Very good. It's an improper fraction, right? It's an improper fraction. So that means it can be changed into a mixed fraction.
Yeah.
First of all, tell me, can I say 4 by 1 is equal to 4?
Yeah.
Yes. Okay. Because it's divided by 1, so it remains the same. 4 by, whether you write 4 by 1 or you write 4, it's the same thing. So 4 by 1 is equal to 4. That means you can change it into a mixed fraction. So tell me, how do we change it into a mixed fraction?
We multiply 1 and 4. No, sorry, we divide them.
Yes, we divide. We say, what do we say? 4
One,
divided by 1?
yeah, like that.
Right. Okay. So before you do the whole thing, let me just tell you that this in mixed fraction, this is equal to 4. Okay. Or rather, it is equal to,
It's going to be 4 by 1. It is going to be 4 by 1.
okay, let's do this. So it says 1, 4 by 1, 4, right? So 1 multiplied by 4, that's
And
4,
4.
and then 0, right? Denominator is what? I'm sorry, remainder is what?
0.
0. So now this will be equal to, how do we do this? We say this comes over here, this goes in the numerator, and this comes in the denominator, right? So this becomes my main number. This becomes my denominator. It comes
4 by
down.
1.
No, it is 4, 0 by 1. Because 0 will go to the numerator. Remember this. There is an anti-clockwise cycle. Okay. Whatever is over here, it will go to the left. This thing will come down, and this remainder will go to the top. That means that 0 will be on the top, 1 will be down, right? 1 will be down, so that will be the denominator, and 4 will be the main number. So they will all swap their positions when you make them into a mixed fraction. Is that clear?
Yeah.
Pakka?
Yeah.
Okay, so 4, 0 by 1. Can you tell me what does this mean? Let me just erase this part. If I say 3, 1 by 1, what does this mean?
4 by 1.
Yes, this means 4 by 1. So are these two equal, 3, 1 by 1 and 4 by 1?
Yeah.
Yes. So can we say, and how are these equal? So you did it that way. Which way did you do? You said 1 multiplied by 3, and then 3, that is 3, and then plus 1, that is 4. So that's the way that you did it.
Yeah.
But look at my way. My way is this: 3, I say 3, and then basically what I do is I just put a plus sign in between both of them, and I say 1 by 1. So that means 3 plus, what is 1 by 1?
1.
1. And what is 3 plus 1?
4.
4. So are you seeing that both of them are the same thing?
Yeah.
Yeah. Okay. Now, Hiba, this is 4 by 1 and this is 17 by 3, right?
Yeah.
Now, there are two ways of doing this. One way is how you used to compare fractions in your 6th grade. Do you remember how to compare fractions?
Yeah, kind of.
Kind of, right? So, we'll come to that in a while. But before that, let me just tell you. So you said 4 will be bigger. Are you sure? Or do you want to change your answer? Or do you want to go into further details as to, do you want to solve it and see what happens?
We can solve.
Yeah, okay, so let's see what happens. So this 17 by 3, can we divide it through this method that we used over here? Can we divide it and make it into a mixed fraction?
Yeah.
Tell me how that will be done.
3 divided by 7.
No.
So 17.
17 divided by 3.
Yeah. And
right?
Yeah. 15 by 5.
Yeah. So 3 5s are 15. What's the remainder? 2?
Yeah.
Yeah. So what I'm going to do is I'm going to The 3 will come down, 2 will go up, and 5 will come over here. Okay.
5 2 by 3.
Yes. 5 2 by 3. What this means is this is equal to 5 plus 2/3 of something. That means if I am making a comparison between, let's say again, rotis, okay, then that means this is equal to 4 rotis, and this is equal to 5 and 2 by 3 rotis. So now tell me which one is bigger.
17 by 3.
Yes, 17 by 3. So
The
did you
answer
see
going to
how?
be 17.
Sorry?
After multiplying 5 and 3 and then adding 2 to the answer, it's going to be 17, right?
Yes, 17 by 3. Is that clear, Hiba?
Yeah.
Okay. All right. So do you want to do a few more questions on this type?
Yeah.
Yeah. I think actually we should hurry up because we don't have many classes. Oh yeah, before I forget, are you okay with having classes on Thursdays and Tuesdays? Because before your test, we have only one Tuesday remaining. And I think your test is on Friday, if I'm not wrong.
Thursday, next Thursday.
When is your test? Your test is on 30th, right? Yeah, it's on Thursday.
It's on next Thursday.
Yeah, it's on next Thursday. So before that, can we have a class on coming Thursday and then the Tuesday after that? So the Tuesday is going to be 28th. So coming Thursday is 23rd, I think. Basically, yeah, tomorrow.
Yeah.
Thursday and Tuesday. So that's 28th. So Hiba, from now, you will have classes until your test. You will have classes on all days except for Saturday and Sunday. Okay?
Okay. Monday also?
Yes, Monday, Tuesday, Wednesday, Thursday, Friday. Just not Saturday and Sunday. Okay, and today you joined exactly on time, so I would like to appreciate you for that. Thank you very much for joining on time. Right.
You're
So
welcome.
it really helps. Okay, so Hiba, one more thing. For your classes on Tuesdays and Thursdays, it will be the same time, right?
Yeah.
Okay. So I will ask the team to send you a reminder for the class on the day that is happening. So please join on time, okay?
Okay.
So until your test, we will have like a few more, like 2 more classes that will help us a little bit. Okay. So let me just give you a few questions for practice. So let's say I have a rectangular sheet of paper. Okay, before we go further, let me just revise what all we've done. Hiba, what does this mean?
$25 by 2.
Okay, 25 by 2. Any other way that we can call it?
Mixed fraction.
Mixed fraction. Okay. How else can I call it?
12 plus 1 by 2.
Okay. Okay. And if I say I have eaten these many number of, okay, I won't say rotis, that will be a little weird. If I say I've eaten these many number of sweets,
Yeah.
then what does it mean? How many, like how can I say it in my daily language? Yes, 12 and a half, right? This is 12 and a half. Okay. I just want to say one more thing. Okay. So let's say I have this and this is my one circle. This is another circle. I am dividing it in 4 equal halves. Let's say that's a pizza. Okay. Do you like pizza, Hiba?
Yeah.
Yeah, me too. I like pizza too. Okay, so let's say, Hiba, we ordered two different types of pizzas. We're having a party, we ordered two different types of pizzas. So this is a different type of pizza. Let's say this is like, I don't know, this has cheese
Barbecue.
and, very good. Okay, good. This is a barbecue pizza. Okay, what's the other type of pizza?
Dynamite.
I'm sorry.
Dynamite.
Okay, that's a dynamite pizza. So now we ordered this, and let's say there are like a few kids roaming around. Thing is, we want one bite from, oh, you know what, I think two pizzas are too less. You can never have enough pizza, so I'm gonna order one more. Okay, I'm gonna order one more, and just name this one also.
Beef.
All right, a beef pizza, or let's call it a pineapple pizza. I know a lot of people don't like that, but let's just name it that. Okay, so now, Hiba, if you are to have if you are to have 1/4 of this pizza, okay, one slice from this pizza, so that is 1/4, okay, and then 1/4 from this pizza, and then you're gonna have 1/4 from this pizza. So can you tell me total how many pizzas have you eaten?
Three. 3/12.
3/12 pizzas you have eaten? No. See, okay, Hiba, when you say that I have eaten 4/4, that is equal to 1, that means you have eaten one pizza. Okay. If you have eaten all 4, that means you have eaten one pizza. Is that clear? Yeah. Yeah. So this is 1/4. How much is this? Look at just this pizza. Okay. This is 1/4. This is 1/4. Okay. How much is this? This is also 1/4 of this pizza.
Yeah.
How much is this?
1/4.
This is also 1/4 of this pizza. So you have eaten 1/4 plus 1/4 plus 1/4. That is equal to how much? 3/4. So you can say this is basically 3 times 1/4, right? 1/4 is how many times? 3 times. So you have eaten 3 times 1/4. And what happens is that we multiply the numerators with each other. Okay, so this becomes 3 multiplied by 1 is 3. So that is 3/4. So how much have you eaten? You have eaten 3/4 of a pizza. And if you don't believe me, I will show you. Wait a minute. Let's say I'm gonna put that over here. Okay, let's just put all these pieces together. Yeah. Okay, so you have eaten 1/4 from the BBQ, right? From the barbecue thing. So that's your barbecue pizza. So basically your stomach knows that you have eaten 1/4. I'm sorry, you have eaten 3/4 of a pizza because it has gotten 3 different pieces of 1/4, 1/4, 1/4 each. So that gives you 3/4. So you have eaten 3/4 of a pizza. And let me just show you that. Okay, quickly, I'll show you that. So that's the barbecue pizza. And then, oops. This is your second pizza, which is the dynamite pizza. Okay. And again, this, I am not able to draw it very smoothly, but you can understand. This is your pineapple pizza. So what does it look like, Hiba? How much of a pizza have you eaten?
by 4.
Yes, you have eaten 3/4 of a pizza, right? So the total value that has gotten into your stomach is 3/4. So you understood this concept, right? That this is what I wanted to show you, that 1/4 plus 1/4 plus 1/4, that is 3 times 1/4, and hence that is equal to 3/4. Understood?
Yeah.
Okay. So now let's quickly come to this. So basically, I have a paper. And I want to calculate I have a sheet of paper and I want to calculate how much of tape I need to put across its borders. Maybe I'm doing a project or something. I need to put some decorative tape along its borders. So I want to calculate how much tape I need to put. So for that, what do I need to calculate? Should I calculate its perimeter or should I calculate its area?
Area.
I need to put the tape along the border. Perimeter. You do know the perimeter and area, right?
Yeah.
Yes. Okay, so that's my decorative border I'm going to put. For that, I need to calculate the perimeter. Very good. So I will tell you the measurements of the sheet. So my sheet is basically 12. Okay, not 12. Usually an A4 sheet is, okay, fine. I'll just write like 14.5. Okay, 14.5. My sheet is 14.5 centimeters long and it is 10.5 centimeters wide. Okay. Can you calculate how much border will I need or how much decorative tape will I need?
10.5.
Okay, 10.5. Then my 10.5 is the width. Okay, 14.5 is the length. Your voice is breaking.
Breadth multiplied by length.
Can you repeat?
Breadth multiplied by length.
And that gives you, does it give you the perimeter or area?
Perimeter. Sorry, area.
That gives you area, right? Okay, let's not go to the formula. Okay, forget the formula for now. If you have to calculate the length of the border, so 1 minute. This is my border, Hiba. Okay, I'm starting to put the border from here. Okay, if I put the border only on this side of the paper, how much border have I put?
10.5.
10.5 centimeters, right?
Yeah.
10.5 centimeters. Very good. Then again, I put the border on this side of the paper. Now, how much border have I put on this side?
I can't see the number.
Oh, you can't see the number? I'm so sorry. Wait, let me just move the whole thing. Now, are you able to see it?
Yeah.
Okay. Okay, wait, 1 minute. So till now, forget about this pink thing. Okay. Till now, I have put 10.5 centimeters, the purple thing. Then I put the pink thing. I started putting the pink thing. How much have I put it?
1/2. 14 1/2.
14 1/2. How do I call it? That is equal to 14.5. Very good, 14.5. Then again, I start putting more. I start applying more tape. I put it along this edge, the red one. So how much have I put now?
Plus 10.5.
Plus 10.5. Very good. Okay, then again.
Plus 14.5.
Very good. Plus 14.5. Okay, that's plus 14.5. So what is this whole thing equal to? Now, can I just take this one this 14 and a half, and this 14 and a half. Can I take them together?
Yeah.
14 and a half plus 14 and a half. Now, can you tell me 14 and a half plus 14 and a half? That gives you 2 times 14 and a half, right?
Yeah.
So can I say that is equal to 2 times 14 and a half?
Yeah.
Okay. Now, can I take this part, 10 and a half plus 10 and a half, and say this is equal to 2 times 10 and a half?
Yeah.
Yeah. Okay. So now can you tell me what will this be equal to? Okay, let's see this. So 2 times 14 and a half. So 14 and a half, that will be
29 by 2.
2. Very good. 29 by 2. Okay, so this is my one thing. Plus the other will be
21 by 2.
21 by 2. Excellent. So Hiba, you do know that we can cancel the numerator and the denominator, right?
Yeah.
Yes, do you know this?
Yeah.
Very good. So what happens now when we cancel the numerator and the denominator? What do we get?
29 plus 21.
Very good. 29 plus 21. And that is equal to? You're muted. Yes, Hiba?
50.
50. Very good. That is equal to 50 centimeters. So that is the border. That's the perimeter that you need. Okay. So Hiba, we will keep this class till here for today. And I will soon be sending you a worksheet that you'll need to complete. And you have to send it to me on WhatsApp itself. Okay. I will correct it, and if there are any wrong answers, then we'll discuss it in the next class. Okay? Is that all right, Hiba?
Yeah.
Okay then.